Welcome to the Deep Dive. Today, we're tackling a really big challenge of our digital world. The internet, it's given us access to just oceans of information, hasn't it? We can all swim in it. But it never gave us a compass for meaning. So much data is just a stream. It only becomes useful when we, humans, add the context, figure out where it came from, its relevance. But what if we could automate that? What if understanding could be at our command? That's what we're exploring today with IXO, this really interesting solution founded about a decade back. Our mission for this deep dive is to really unpack how IXO builds what they call a living knowledge fabric. The goal is to transform raw data into knowledge you can actually verify and use for real impact.
That really is the core issue, isn't it? We're swimming, maybe drowning in data, but starved for intelligence we can act on. And what I find compelling about IXO is how it tries to bridge that gap. It's not just about getting more info, it's about creating a system where the information itself is trustworthy and ready to go.
Let's start right at the foundation. How do they build this verifiable knowledge? It starts with something called ontologies. They have this great phrase for it, a common grammar for impact. So IXO basically encodes these special vocabularies as domain ontologies. Think of them like machine-readable definitions for all the important stuff in a specific area. So for them, that could be, defining a cook stove or even something like a child health outcome. And crucially, it's not just defining the things, it's defining how they relate.
The real power isn't just having neat definitions, it's what it enables. Semantic interoperability. Which sounds fancy, but it means, let's say a field officer in Zambia makes a claim about some project asset. That claim can then be understood, reasoned over by an AI agent, maybe in Singapore, without losing meaning. It's like a universal language for impact data. How could this kind of common language change how data is shared? Think about health, energy, or climate change, sectors where incompatible data has always been a huge hurdle.
That shared vocabulary, that common grammar. What's next? IXO then weaves this into semantic graphs. So if ontologies are the words,
then the graphs are the sentences.
They become sentences of verified facts, connected facts. Each fact in these graphs, we call it triple, like a subject, predicate, object. So this cook stove belongs to that household. Simple statement. Each one carries cryptographic signatures, which means you can link that fact back to its source. So you're not just storing claims, you're building this living graph where every single piece of information is attested. You can check its origin.
And the graph structure itself is so vital because, real systems, real change, it happens through relationships, connections of single reading, like an emission number. By itself, it doesn't tell you much. But when you connect it, okay, this reading came from this device, which is in this household, and that household relates to this sustainable development goal indicator, maybe it's linked to a financing contract, and you add a timestamp. That whole network of connections, that's what turns raw data into useful intelligence.
It's the context.
The web of verifiable relationships makes it meaningful.
So you've got the words, the sentences forming a graph. How do you anchor it all, make sure it's solid? That's where the blockchain comes in. IXO uses a layer 1 chain. And every assertion, every fact gets committed as a node in something called a directed acyclic graph, a DAG. It's basically a chain of time-stamped blocks. An immutable ledger. You can't change the past. They have this really evocative description for it. They call it the memory palace of each cognitive digital twin.
That memory palace idea, it's quite fitting because a DAG, you can think of it maybe like a family tree for information. Every new piece of data traces its lineage back through previous verified facts. But crucially, it's a cyclic, no loops, no going back in circles. It always moves forward in time. So what does that let you do? Say you want to know the current state of a whole fleet of cook stoves. You can reconstruct it precisely by walking this DAG, applying all the recorded changes in the right order, and if someone disputes the data, say data quality issues, you can trace the proofs right back to the original signed record on the chain. It resolves disputes definitively, and this is really powerful. It means smart contracts can automatically trigger payments like outcome-based finance the very moment the system verifies that the agreed conditions have been met, based on that unshakable data record.
Wow, so it provides this solid foundation.
Absolutely. Truly verifiable, actionable data relies on that kind of unshakable history.
So let's bring it all together then. You've got the ontologies, the common words. You've got the semantic graphs, the connected attested sentences, and the blockchain providing that immutable history, that memory palace. Put them all together, and you get what IXO calls cognitive digital twins, which are essentially software representations of real-world things or systems, but intelligent ones. They can perceive, they can predict, and they can learn. They can perceive by taking in all sorts of data, sensor streams, satellite images, transactions, surveys, you name it. Then they can project by running models, like causal models, but always anchored in that verified ground truth from the graph. And importantly, they learn. As new verified data comes in, you always know why it believes something, tracing it back through the DAG.
And these twins, they're not just working in isolation. They act as collective intelligence nodes. So imagine you have twins for individual stoves interacting within households, then twins for those households interacting within regions. And maybe those regions are part of a national climate mitigation program. When they all interact based on that shared verified data fabric, you get this emergent understanding across multiple scales that no single person or organization could possibly put together on their own.
It scales up the
It
intelligence.
turns lots of little data points into a connected, evolving, verifiable intelligence.
This is where it gets really interesting. Seeing how this architecture plays out in the real world. Let's talk about MRV, measurement, reporting, and verification.
Ah, yes, the traditional headache for many impact projects.
Exactly. Traditional MRV, it's always felt a bit slow, episodic. You measure maybe once a year, the audit happens months later. By the time you get the report, the chance to actually use that information to adjust things in real time is long gone. It's too late.
A compliance exercise.
But IXO aims to flip that completely. They make MRV event-driven, a near real-time control loop. And it seems to work in 3 steps. First, measure. New data comes in, it gets checked against the ontology, validated semantically.
Okay, so it checks if the data makes sense according to the shared language.
Then second, report. If there's a change, the twin immediately publishes that state change, along with a confidence score, straight to the blockchain, to the DAG.
Instantly recorded.
Instantly. And then third, verify. Independent systems, they call them oracles, can automatically rerun the reasoning, check the proofs on the chain, and sign off automatically.
So the whole process becomes automated and continuous. The significance is pretty profound because the whole pipeline is machine interpretable. MRV stops being this slow compliance burden. It becomes a near real-time control loop, feedback that can actually guide actions now. It makes you wonder how many other traditional processes, these slow, cumbersome reporting cycles in different industries, could be revolutionized by this kind of continuous, automated, verifiable approach. The potential seems huge.
You can see applications far beyond just environmental projects. And looking even further ahead, they're doing some cutting-edge work fusing this with large language models, LLMs.
Ah, AI everyone's talking about. How does that fit in?
It's a clever fusion, playing to the strengths of both. LLMs, they're amazing at understanding language, recognizing patterns, but they can also sometimes hallucinate, make stuff up if they don't have solid facts to ground them.
They lack that grounding in verifiable truth sometimes.
Exactly. Whereas knowledge graphs, like the ones IXO builds, are all about precision, verifiable facts linked to sources. But they often need careful, sometimes manual curation to build them.
So different strengths, different weaknesses.
Precisely. So IXO fuses them. An LLM agent can ask a question of a digital twin using just plain English.
Okay, so natural language interaction.
Yeah. The twin then translates that question into a precise query language, SparQL, to search its own knowledge graph. It fetches the exact, grounded facts related to the query and returns a traceable answer back to the LLM and thus to the user, an answer rooted in verified data.
So the LLM handles the interface, the twin handles the factual retrieval.
Basically, yes. And it goes further. The same LLM, if it encounters new concepts out in the field data, it can actually propose extensions to the ontology, suggest new terms or relationships. But crucially, that's subject to human governance, human review.
The intuition of the LLM meets the logic of the graph. It sounds like they can co-evolve, each correcting the other's blind spots. The LLM brings the broad pattern matching. The graph brings the hard verifiable grounding. It really points toward a more robust, reliable kind of AI in the future. One that doesn't just rely on statistical correlations, but anchors its insights in facts you can trace and trust.
AI with receipts.
I like that.
So, okay, we've gone through the tech, the applications. Let's zoom out. What does this all mean? Why does having understanding at our command built this way actually matter? What are the implications?
Well, it fundamentally changes the game for accountability and trust.
Looking at the source materials, they spell out some pretty clear benefits for different groups. For investors, for example, they get auditable proof that their money is achieving real outcomes, not just funding activities.
Huge for impact investing, results-based finance.
For communities on the ground, they can earn trusted credentials based on the verified impact they're creating. And that could unlock new kinds of finance, adaptive finance, that responds to their actual progress.
Empowering local actors with credible data.
For policymakers, instead of waiting for last year's statistics, They could get forward-looking intelligence based on near real-time verified data. Much better for planning.
A massive improvement over lagging indicators.
Even for developers building new applications or models, they get this composable stack. Every new piece of verified data strengthens the shared understanding, the shared model of reality. It builds on itself.
It's about fundamentally shifting how we interact with data, moving beyond just information overload towards genuine verifiable knowledge. It's not just about accessing stuff anymore. It's about generating real-world impact you can prove. And doing that faster, with more confidence. This could really transform sectors by baking trust and transparency right into the data layer itself, enabling completely new ways to collaborate, to invest, all based on evidence you can actually rely on.
Quite a journey today, diving into IXO's architecture. It's intricate, definitely complex in parts, but the potential seems enormous. It really brings us back to that idea from the start. The first wave of the internet gave us information at our fingertips. Maybe this next wave, this internet of impact, needs to give us understanding at our command. And IXO's approach, ontology-driven, graph-anchored, blockchain-grounded well, this certainly looks like one very pragmatic path towards that future, building that verifiable fabric.
As you, the listener, think about all this, here's a final thought to consider. What critical decision in your own field or life would remain just guesswork tomorrow if we fail to encode its evidence base today? And conversely, what new possibilities might open up once the evidence can actually start to think for itself?
A powerful question to leave us with. Food for thought. Thank you for joining us on this deep dive into the fascinating world of IXO and the future of verifiable knowledge.